Hello and welcome again to Flipped Harbor for Precalculus. In this video we'll be talking about Cramers rule and matrix equations. Our topics for this video are going to be looking at systems of equations and turning those into matrix equations and using Cramers rule to solve those systems of equations. Our objectives by the end of this lesson, you need to be able to use Cramers rule to find the solutions for both 2x2 and 3x3 systems. You need to be able to write a matrix equation for 2x2 and 3x3 systems. And you need to be able to use that matrix equation to find solutions for the 2x2 and the 3x3 systems. Now, let's start with this system of equations, and we're going to solve it by using a process called Cramers rule. Now, what we need to do is find three different determinants. So three determinants for slightly different matrices. And we're going to call these D, standing for determinant obviously, D sub X, I'll explain the differences in a minute, and D sub Y. So I've got my determinant notation, those straight bars, for all three of my determinants. And you'll notice that in D, all this is my coefficients from my system of equations. So this is just the determinant of what I like to refer to as the coefficient matrix. Now D sub X is very similar, but you'll notice that this X column, this column where the X coefficients were, has been replaced by my two answers, has been replaced by those numbers on the other side of the equations. So I like to remember that D sub X, the X column has been replaced. Well, that kind of implies that in D sub Y, the Y column has been replaced. So this second column has been replaced by these answer numbers. So in D sub X, it's the coefficient matrix with the X column replaced. In D sub Y, it's the coefficient matrix with the Y column replaced. And we need to find the determinants for all three of these matrices. Now remember, 2x2 matrix, to find our determinant, we take the product of the primary diagonal minus the product of the secondary diagonal. So when we do that for D, we get a determinant of -1. When we do that for D sub X and D sub Y, we get -18 and -32. Now let's put this together in order to get our two solutions for the system of equation. Our two solutions, one for X and one for Y. The way that we find X, we take D sub X and divide it by D. So we take the determinant of that special X matrix and we divide by our basic determinant D. In that case, we're taking -18 and dividing by -1, which is obviously going to give us 18. Now, you can probably guess how we're going to find Y. We take D sub Y and divide it by D. So we're taking -32 divided by -1, and our solution for Y is 32. Now, the same process can be done if we have a system with three variables. Let me move this bar up here to the top. We need to find four determinants of matrices. We need to find D, that's the basic coefficient matrix. Notice the 0 right here. We have a 0 right here because we had no Z term right there. So whenever we're missing a term, that coefficient is 0 in all the matrices where it shows up. D sub X has that X column replaced. D sub Y has that Y column replaced. And D sub Z has that Z column replaced. Now remember the process for finding a determinant for a 3x3. We add the two columns on, we do the diagonals, minus, and we do the diagonals. But if you go through and figure out your determinants for all four of these matrices, D is equal to 6, D sub X is equal to -3, d sub y is equal to negative 3, and d sub z is equal to 24. So just like the 2 by 2 system, we're going to find our x, our y, and our z by taking d sub x divided by d sub y divided by d, and finally d sub z divided by d. So our solution for this system of equations is x equals negative 1/2, y equals negative 1/2, and z equals 4. Now, let's take a look at another way to solve a system of equations. And it all starts with learning how to write a matrix equation. So we're going to take a look at how to write a matrix equation for a 2 by 2 system. When I say a 2 by 2 system, I call it that for several reasons. One, we're going to be creating a 2 by 2 matrix, but it's also 2 equations with 2 unknowns, so 2 by 2. And it starts with a matrix. Now notice the notation here. Our bars are there. This isn't the determinant of this matrix. This is just the matrix, and it's our coefficient matrix again. We take the 6 and the negative 4 from our x's. They become this first column. We take the 1 and the negative 5 from the y, and that becomes our second column. So again, I like to refer to this as the coefficient matrix. So it all starts out with a 2 by 2 matrix made from the coefficients. Now that gets multiplied by our x and y laid out as a column. Okay, the x and the y become a 2 by 1 matrix where it's in a column rather than in a row. And you know, that makes sense when you think about what sizes we could multiply this 2 by 2 matrix by. I couldn't multiply them by a 1 by 2 matrix, so x and y have to be laid out as a 2 by 2. And then on the other side of an equal sign, well, what do you think goes there? Well, the two answers laid out as a column go there, so the negative 8 and the 12. So this is how we turn this system of equations into a matrix equation. Now let's talk about the idea behind what this matrix equation will do for us, and then we'll talk about how to actually get there. So if I had the identity matrix in front, if instead of 6, 1, negative 4, negative 5, if I had the identity matrix 1, 0, 0, 1, well, in those two boxes would be what x equals and what y equals. So what we're really going to do is some math in order to get the identity matrix in front of my xy matrix. Now if you stop and think about that, the way that I get the identity matrix is I multiply that matrix in front by its inverse. So I need to take the inverse of the coefficient matrix and multiply my coefficient matrix by it. That's going to create this identity matrix. Now, you know, standard algebraic rule here. Whatever I do on one side, I have to do on the other. And I have to do this very specifically because this inverse right here is multiplied in front, and because multiplication is not commutative with matrices, I've got to make sure that I put it in front on the other side. So it absolutely has to go there. Okay, no ifs, no ands, no buts. That inverse matrix has to be in front on both sides. So we know how to make an inverse matrix. We go through our process of making that inverse matrix, plop it in front, and that's going to make that identity matrix again. So if you go through all this hard work for making the inverse matrix, do not focus your work here in the front. Don't spend time multiplying these two matrices together. If you did a good job of finding your inverse matrix, this will create the identity. Don't spend your time there, okay? Just let this be the identity matrix. Spend your time back here doing this product. That's going to create your two answers as long as you do it right. So that's where you spend your time. Don't spend your time up front. You spent the time creating the inverse. That's going to create the identity. spend your time multiplying at the back. And once you do, you've got your two answers. So my solution for this system of equations is x equals -2, y equals 4. Now, I can do the exact same thing for a 3 by 3 system of equations. I'm still going to create a coefficient matrix. It's going to multiply a variable matrix laid out in columns, and that's going to equal my answer matrix laid out in a column. Notice the zeros because I've got no x term in my first equation. I've got no y term in my second equation. So I put zeros there. Now, how do we find the inverse for a 3 by 3? Oh yeah, we get to just use our fancy calculators. So you find this inverse matrix by just using your calculator. Go ahead, multiply back here. Don't spend your time up front. Spend your time doing this product right here. The product in front should just create your identity. So don't spend your time up here. Okay? Once we multiply, we get the identity matrix in the front because our calculator did a good job. And at the back, we get our solutions. So this one is x equals -1, y equals 7, and z equals -2. That's it for this video, so it's time for you to get to work. I'll see you in class, and I'll see you online.